Hello everyone, welcome you all. In this video, we will discuss the MCQs from solid state physics. All the important and selected questions have been taken, which will be very much helpful in your upcoming exams. As you know, there are various important topics in solid state physics. So in this video, we will discuss the MCQs from crystal structure, reciprocal lattice, X-ray diffraction, then free electron theory and band theory of solids. And in the next video, we will discuss the MCQs from semiconductors, magnetic properties of materials and superconductors. Okay, let's start. Question number 1. The packing fraction of a simple cubic lattice is approximately. We know for a simple cubic lattice, the packing fraction is 52%. Okay, so your correct option is option A. Similarly, you should remember for BCC, body center cubic, it is 68%, and for FCC, it is 74%, and for HCV, it is also 74%, and for diamond cubic, it is 34%. Okay. Similar way, you can remember this is like this also, like this 52% is expressed as 5/6. Then for BCC, it is √3 pi/8. For FCC, this is √2 pi/6. Similar for SCP, that is √2 pi/6. And for diamond cubic, it is √3 pi/16. Okay. Next, consider X-ray diffraction from a crystal with a face center cubic lattice. The lattice plane for which there is no diffraction peak is. Okay. See, we know for FCC, H, K, and L value should be all even or all odd. Okay, so you can check option. In option A, this is even, odd, even. So from this plane, there will be no diffraction peak. So this is your correct option. Similar way, you should remember for BCC and simple cubic. For BCC, H plus K plus L value should be equals to even. Okay, and for simple cubic, all HKL values are allowed. Next, the Hall coefficient depends on. Okay, so here you have to remember the expression for Hall coefficient, and that is RH. RH is given by 1 by NE. So you can check the option here. This Hall coefficient depends on the charge carrier density only. So your correct option is option C. Next, the order of magnitude of the energy gap of a typical superconductor is 1 milli electron volt. Next, for an intrinsic semiconductor, Me and Mh are respectively the effective masses of electrons and holes near the corresponding band edges. At a finite temperature, the position of the Fermi level. Okay. See, so it is given that this is an intrinsic semiconductor, and for intrinsic semiconductor, we know the Fermi level is given by Ec plus Ev by 2 plus 3/4 kBt ln mh star by me star. So this at finite temperature, the position of the Fermi level depends both on effective mass of electron and mass of hole. Okay, so C is your correct option. Next, a simple cubic crystal with lattice parameter A undergoes a transition into tetragonal structure with lattice parameters AT equals to BT equals to √2A and CT equals to 2A below a certain temperature. The ratio of the interplanar spacing of 101 planes for the cubic and the tetragonal structure is. Okay. So we know the interplanar spacing is given by 1 by d equals to 1 by square root under h square by a square plus k square by b square plus l square by c square. This is the general expression. Okay, and for cubic we know a equals to b equals to c for cubic, and for tetragonal a equals to b not equal to c. Okay, so for cubic it will be a by square root under h square plus k square plus l square, and for tetragonal it will be 1 by h square plus k square by a square plus l square by c square. Now we can put the values of HKL, that is 101, and value of AT and BT for tetragonal from this given values. So here for a cubic, D will be equals to DC, interplanar spacing for cubic will be A by root 2, and for tetragonal this is equals to 1 by square root under 1 by 2a square plus 1 by 4a square. Okay, so this is equals to a divided square root under 6 by 8, so it is 3 4, so this will be equals to 2a by root 3. Now if you take the ratio, then it will be dc by dt will be equals to square root under 3 by 8. C is your correct option. Next, considering the BCS theory of superconductors, which one of the following statements is not correct? Okay. So presence of energy gap at a temperature below the critical temperature, different critical temperatures for isotope, quantization of magnetic flux in superconduction ring in the unit of H by E. But we know this is in the unit of H by 2E. Okay, so this statement is not correct. So C is your correct option. This is in SI unit. Okay, so if they ask you with CGS unit, then it will be HC by 2A. Next, if the number density of a free electron gas in 3 dimensions is increased 8 times, its Fermi temperature will. Okay. So here first you have to express the Fermi energy in terms of this number density. Okay, and this is equals to h square, square by 2m 3 pi square n 2 by 3, and we know Fermi energy is equals to kb times Ef. Okay, so from here you can calculate the change in the Fermi energy, that if you put the value that is given 8 times, so 8 to the power 2 by 3. Okay, so it will be 4 times. So H energy is increasing 4 times, so temperature is will also increase 4 times. So increase by a factor of 4. So correct option is option A. Next, the number of point groups in 2 and 3 dimensions are respectively. Number of point groups in 2 and 3 dimensions, that is your 10 and 32. For 2 dimension it is 10, and for 3 dimension it is 32. So A is your correct option. Next, what is the possible number of different types of lattice in 3D? Different type of lattice in 3D, that is 14. So C is your correct option. Remember, in 2 dimension possible different type of lattice will be 5, and in 3 dimension it is 14. But if they ask crystal system, in 2D crystal system is 4, and in 3D crystal system is 7. Okay, this is crystal system, and this is lattices. Next, crystal system having axial distance A not equals to B not equals to C, and axial angle alpha not equal to beta not equal to gamma not equal to 90 degree. So this corresponds to triclinic. Okay. Similarly, you should remember for other 6 crystal system. Next, the number of atoms in the unit cell of body center Q. For BCC, it is 2. Next, for simple cubic, you should remember number of atoms per unit cell is 1. For BCC, it is 2. For FCC, it is 4. And for HCV, it is 6. The number of atoms in phase center Q per unit cell, it is 4. So, C is your correct option. Which of the following elements is a semiconductor? Germanium. So, correct option is option D. Next, which type of semiconductor is obtained by doping silicon with phosphorus? Okay, see, phosphorus is a pentavalent impurity. So, it will result in a N-type semiconductor. So, A is your correct option. Next, which theory is useful in explaining electrical conductivity in conductors and semiconductors? This is your band theory. So, C is your correct option. What is the percentage of empty space in BCC structure? Okay, we have discussed for BCC structure, the atomic packing fraction is 68%. So, empty space will be 100 minus 68%. So, it will be 32%. So, C is your correct answer. Next, for a hexagonal crystal system, which of the following sets of parameters of axial distance and axial angles is correct? For hexagonal system, we know A equals to B, not equal to C, and alpha equals to beta equals to 90 degree, and gamma equals to 120 degree. Okay, so you can check the options. This is D. D is your correct option. Next, what is the empty space in hexagonal closed packing arrangement of a crystal? We know for hexagonal closed pack structure, atomic packing fraction is 74%. Atomic packing fraction. So empty space will be 26%. So A is your correct option. Next, which of the following is a crystalline solid? So you can check the options. Anisotropic substances are crystalline solids. So B is your correct option. Next, the valence electrons do not directly determine the following property of a metal. So this shear modulus. C is your correct option. The target of an X-ray tube is subjected to an excitation voltage V. The wavelength of the emitted X-ray is proportional to 1 by V. So C is your correct option. The number of crystal systems possible in 2 dimensions is 5. The number of Bravais lattice possible in 3 dimensions is 7. Okay, now we will discuss some question that I asked in the previous exam, like in GATE and NET exam. Okay. So the temperature dependence of magnetic susceptibility of a ferromagnetic substance with a Curie temperature is given by C by T minus Tc for temperature greater than Tc. Okay, so B is your correct option. Next, a lattice has the following primitive vectors. The reciprocal lattice of corresponding to the above lattice. Okay, so here you can see for given lattice, you can see this correspond to FCC. Okay, and we know for a FCC lattice, the reciprocal lattice is BCC. So you can check the option A or B will be correct, but we have to find the cube edge. So to find this cube edge, you have to use the formula, the reciprocal lattice vector formula, that is A star will be equals to 2 pi B cross C divided by A dot B cross C. Okay, so you can check, you will find the cube edge to be of the order of pi by 2. So here A is your correct option. Next, given that R is the radius of the atoms and A is the lattice constant of a solid having a cubic structure, which one of the following relation is true for a body-centered cubic structure? See, for a body center cubic structure. That means you have to take the body diagonal, and for body diagonal we know it is root 3a, that is equals to 4r. Okay, from body diagonal, that is 1 in the body center, that is 1 atom, then another atom in the corner. So this is total 4r, and body diagonal is root 3a. So from here you can check a equals to 4r by root 3. So D is your correct option. Next, what is the second nearest neighbor distance in a FCC lattice whose conventional unit cell parameter is A? Second nearest neighbor distance for FCC is A. Okay, C is your correct option. Similarly, you should remember for all, like for simple cubic, BCC, FCC, HCP. Okay, number of atoms per unit cell. First, you should remember number of atoms per unit cell. Okay, for simple cubic, it is 1, for BCC it is 2, for FCC it is 4, and for HCP it is 6. Similarly, you should remember for diamond cubic, that is 8. Okay, next, number of nearest neighbor atoms. First nearest neighbor atoms, that is 6, 8 for BCC, 8 for FCC, 12, and for HCP it is also 12. And now the distance of first nearest neighbor atoms, that is your A, root 3a by 2. This is a by root 2, and for HCP it is a. Next, second, number of second nearest neighbors. Number of second nearest neighbors. For simple cubic it is 12, for BCC it is 6, for FCC it is 6, and for HCP also it is 6. Similarly, the distance of the second nearest neighbor atoms is root 2a. For BCC it is a, for FCC a, and for HCP root 2. Next, you can remember also number of third nearest neighbor atoms. For simple cubic it is 8, for BCC it is 12, for FCC it is 24, and for HCP it is 2. And their distance of third nearest neighbor atoms. For simple cubic it is root 3a, for BCC it is root 2a, for FCC it is root 3a by root 2, and for HCP this is equals to square root under 8 by 3a. Next, the C by A ratio for an ideal hexagonal closed pack structure is square root under 8 by 3. So D is your correct answer. For a closed pack BCC structure of hard sphere, the lattice constant is related to the sphere of radius. So for BCC, okay, that is root 3a equals to 4r. So A will be 4r equals to root 3. So B is your correct answer. Next, the interplanar spacing for 110 plane of a monoatomic FCC crystal of lattice constant 2a. So A is given, that is 2a. HKL value is given 110. Now you have to find the interplanar spacing. D equals to A divided by square root under h square k square plus h square. Okay. So you can calculate and you will find root 2 Armstrong. So C is your correct option. In the X-ray diffraction pattern of a sodium metal which has a BCC structure, the missing reflection planes will be, we have discussed for BCC structure, H plus K plus L value should be given. So you can check option. Okay, option D is H plus K plus L is odd. So this will be the missing reflection plane in the diffraction pattern. Okay, so D is your correct option. Next, the specific heat of an ideal Fermi gas in 3 dimensions at very low temperature, here is H, P. A is your correct option. Which of the following combination of crystal structure and their coordination number are correct? Coordination number means the first number of first nearest neighbor atoms. Okay, so you can check for BCC it is 8, for diamond it is 4, For face center cubic, this is 12. Okay. For face center cubic, it will be 12, and for hexagonal closed space structure, this is 12. Effective mass of an electron in a semiconductor can be negative near the top of the band, and the effective mass is for electron is positive at the bottom of the end. Bottom of the band. Next, considering the energy E in the first billion joule is a function of the magnitude of the wave vector k for a crystal of lattice constant A, then the slope of E versus k is proportional to the group velocity. Okay, you should remember effective mass is given by h cot square by del square E by del k square, and the group velocity Vg equals to 1 by h cot del E by del k. So the slope of E versus k graph will give you the group velocity. So here is correct option is option A. Consider the Fermi-Dirac distribution function at room temperature 300 Kelvin, where E refers to energy if EF is the Fermi energy. Which of the following is true? F is a step function. If EF has a value of half. Okay, so here you can use the Fermi-Dirac distribution function is given F equals to 1 by exponential E minus EF by kBT plus 1. So you can check for energy E equals to EF, this will give you the value half. Okay, so here your correct option is option B. The effective mass of an electron in a semiconductor can be positive or negative, both possible. Okay, C is your correct option. For a closed peak BCC structure of hard sphere, the lattice constant A is related to the sphere radius discussed. A equals to 4r by root 3. Which one of the following axis of rotation symmetry is not permissible in single crystal? That is your 5-fold axis. Okay. So D is your correct option. A superconducting ring is cooled in the presence of a magnetic field below its critical temperature. The total magnetic flux passes through the ring is n times h by 2e. Okay. So B is your correct option. Which one of the following is the first order phase transition? Okay, so here you can check vaporization of a liquid at its boiling point is a first order phase transition. All the other options like ferromagnetic to paramagnetic, normal liquid helium to superfluid helium, superconducting to normal state, all these are second order phase transition. And similar here also you should remember vaporization of a liquid at its critical point. At its critical point is a second order phase transition. Okay. Next. Which one of the following is not a correct statement about semiconductors? Okay, so here you can check option C. It is given that silicon is a direct band gap semiconductor, but we know silicon and germanium are indirect band gap semiconductor. Indirect band gap semiconductor. Okay, so C is not correct. Next, probability that an electron in a metal occupies the Fermi level at any temperature, okay, will be half. So C is your correct option. Next, the critical magnetic field for a solid in superconducting state increases if the temperature decreases. C is your correct option. You can remember the critical magnetic temperature at C at any temperature T is given as C0, or that is 1 minus P by Tc whole square. Next, which one of the following is a trivalent material? You can see antimony is a pentavalent, phosphorus also pentavalent, arsenic also pentavalent, but boron is a trivalent material. Okay, so D is your correct option. Next, the increasing temperature, the electrical conductivity would decrease in metals but increase in intrinsic semiconductors. So C is your correct option. Next, the materials not having negative temperature coefficient of resistivity are not having negative temperature of coefficient. So metals. Okay. Next, the Ohm's law for conduction in metal is J equals to sigma. We also know another form, that is V equals to I. Okay. So here A is your correct answer. Okay, so let's stop here. I think this will definitely help you in preparation of your exam. And if you find this video helpful, don't forget to like, share and subscribe to our channel. Thanks for watching. See you in the next one.